My name is Hidalina Binti Sabirin. In this video, I will present about my project for Electrical Power Technology subject. The title of this project is Three-Phase System with Y-Connected Generator. So, let's start with introduction. Three-phase systems are widely used in generation, transmission, and distribution of electric power. The transmission line is made up of conductor having a uniform cross-section area along the line. Air acts as an insulating or dielectric medium between the conductor. It is a pair of generator and load, which is the generator will produce three sinusoidal voltage of equal magnitude and frequency but different in phase by 120 degrees from each other. Three-phase system have two sequence, which is positive sequence ABC and negative sequence ACB. Three-phase system has two types of connection for generator, which is Y-connected generator and delta-connected generator. Same goes to the load connection. For Y-connected three-phase circuit, it has two types of connection, which is 3-wire and 4-wire connection. For safety purpose, the distance between the line and ground is much more. The electrical tower is used for supporting the conductor of the transmission line. Towers are made up of steel for providing high strength to the conductor. For transmitting high voltage over long distance, high voltage direct current is used in the transmission line. The performance of the transmission line depends on the parameter of the line. The transmission line has mainly four parameters, which is resistance, inductance, capacitance, and shunt conductance. These parameters are uniformly distributed along the line. Hence, it is also called the distributed parameter of the transmission line. The analyzed data are obtained from the situation in this project as well as simulated model in PCM software. Next, the objective. There are three objectives in this project. Number one, to familiarize with an electrical system that consists of three-phase Y-connected generator, transmission loss, and load. Number two, to evaluate the parameter of the electrical system in the context of transmission and load impedance, current, voltage, and acceptable voltage drop. Last but not least, to evaluate and analyze the active power absorbed by the load by using the 2-watt meter method and the conventional measuring method. Next, methodology. The value of transmission impedance and load impedance based on matrix number. All related parameters need to be calculated using conventional method, or in easier way to understand is manual calculation. The parameters are reactance, load voltage, line current, phase voltage, and active power. Next, the basic circuit diagram is set up as shown in this figure. The value of VAN, VBN, VCN, transmission impedance, and load impedance is in the correct value. The frequency is set at 50 Hz, same as electric supply application handbook. This is a complete circuit of Y-connected generator and load. The current and voltage probe is placed exactly same as shown in this figure. It is to measure the value of load voltage, line current, line voltage after transmission loss, and active power. Then, the circuit simulation was run, and all the data of the parameter is recorded one by one. Last but not least, the calculated and measured value is compared. Next, result and discussion. In this project, to find the parameter in the electrical system, students are required to use two methods, which is conventional method and measuring method by using PCM software. The electrical system is in positive sequence, which is ABC. Given line voltage is 11 kV and it is assuming that EAB is equal to 11 kV with phase angle 0 degree. As we know, line voltage leads phase voltage by 30 degree. The frequency is 50 Hz according to the Electricity Supply Application Handbook version 3. The impedance value at transmission line and load are given based on metric card number in ohm. The unit of inductive reactance has been calculated in its actual unit, which is Henry, because PCM software cannot analyze the inductive reactance value in ohm. The total impedance has been calculated. The purpose of calculating the total impedance is to find the value of line current, because transmission impedance and load impedance are connected in series. However, to find load voltage, the impedance that is used is only load impedance. Based on the theoretical concept, line current is equal to the phase current because it is in Y-connected circuit. Normally, generator voltage is equal to the load voltage, but in this case, the generator voltage is not equal to the load voltage. It is because this electrical system has transmission loss. Transmission loss occur at transmission line that can cause voltage drop. Active power is calculated using conventional method. Let's take a look. This is sinusoidal graph of load voltage, line current, and line voltage after the transmission loss. The voltage probe, EABL and ECBL, is placed after the transmission impedance. It is because the line voltage need to be found after the voltage drop. The voltage value of EABL and ECBL is used in 2 wattmeter method to calculate active power. Based on the result shown in this table, calculated value is approximately the same with measured value.
The last part is conclusion.
All the objectives are successfully achieved. An electrical system that consists of 3-phase Y-connected generator, transmission loss and the load are familiarized after doing this project. The parameters of the electrical system are successfully can be determined in the context of transmission and load impedance, current, voltage and acceptable voltage drop. The active power absorbed by the load by using 2 wattmeter method and the conventional measuring method is successfully evaluated and analyzed. It can be concluding that conventional value and measured value are approximately the same. All electrical power is generated and distributed in 3-phase system. The power in 3-phase can be constant. The resulting uniform power transmission and less vibration. 3-phase system is more economical than single-phase system. 3-phase system have a lot of advantages, such as 3-phase transmission line require less conductor material than a single-phase line for transmitting the same amount of power at the same voltage. Furthermore, 3-phase machine give a higher output than a single-phase machine. Next, voltage drop occur because of there are transmission impedance, or easier way to say transmission loss. The line current will flow without dropping because the transmission impedance is connected in series with generator and load impedance. 2 wattmeter method is the best way to measure power in the 3-phase system because accurate power measurement obtain whether it is in unbalanced load or balanced load. The current coil is connected in series with any 2 line and the third line on which is no wattmeter connected.